In Chapter 4, we're going to look at triangles, and in particular, we're going to look at congruent triangles. But before we do that, we need to kind of look at some basic properties and ideas that we're going to utilize throughout this chapter. So first of all, remember what a triangle is. I think we all know that a triangle is a polygon with three sides. The interior angles of a triangle are the ones on the inside of the figure, and the exterior angles are angles that are formed when you extend the sides of the triangle. So in other words, if I extend this guy out here, and then I extend this one here, extend that one there, then these angles, the ones that form a linear pair with the red angles, are your exterior angles of the triangle. We don't really work with exterior angles a ton, but there they are nonetheless. Okay? So real quick, classifying a triangle, we could classify a triangle by sides and or by its angles. A scalene triangle has 0 congruent sides. Every side is a different length. An isosceles triangle has at least 2 congruent sides. It could be all 3 congruent sides as well, but isosceles is at least 2 congruent sides. And an equilateral triangle has 3 congruent sides. Okay, notice an equilateral triangle is also an isosceles triangle. An acute triangle has all angles are acute, so 3 acute angles. I know I'm going through this quickly, but the assumption is that you're already familiar with this. Okay, a right triangle has 1 right angle. An obtuse triangle has 1 obtuse angle. Shouldn't say angle, should be angle. There's only 1 obtuse angle. And finally, an equiangular triangle has 3 congruent angles. And again, there you go. Notice an equiangular triangle is also acute. Really, an equiangular triangle, each angle has to be 60 degrees. 180 divided by 3 is 60. Okay, so that's how you classify triangles. The triangle sum theorem simply says that 3 angles in a triangle always add up to 180 degrees. Okay, the sum of the measures of the interior angles of a triangle is 180. That's it. There's nothing more to it. So example 1 here says use the triangle sum theorem to find the indicated angle. So x, 125, and 20 all add up to equal 180. So x plus 145 equals 180. Minus 145 from both sides tells you that the value of x here has to be 35. Okay, so set up your equation using the triangle sum theorem and then utilize basic algebra skills to solve the equation. Okay, example 2 says classify the triangle by sides and by its angles. Well, by angles right here, part A is it's a right triangle. Okay, by the sides, we can't tell. Okay, so we're going to say, actually, I take that back. If they don't mark anything, okay, well then we'll just, the assumption is that none of them are congruent. So we would call this a scalene triangle. Okay, because they don't mark anything. If they don't mark it or give us enough information, then we have to say it's scalene. If I classify it by its sides in part B, again, I'm going to say that guy's scalene because I don't know anything about the side lengths. And clearly, because 100 is bigger than 90, this thing is an obtuse triangle. And in part C, by sides, it's isosceles. It's got these 2 sides are congruent. And then if that's 75 and 75, that makes 150 minus from 180. This guy's up here has got to be 30. 30, 75, and 75 are all less than 90. Therefore, this triangle is an acute triangle. Okay, so just classifying triangles. Nothing too crazy there. And then the exterior angle theorem says the measure of an exterior angle is equal to the sum of the measures of the 2 remote interior. In other words, angle 1 here has to be equal to the measure of angle 2 plus the measure of angle 3. Okay, so in other words, you don't include the angle that forms a linear pair with it, you include the other 2. And that's the exterior angle theorem. It should make sense because, again, inside this triangle, the 3 angles have to add up to 180. And this linear pair, these angles have to add up to 180. All right, and so since this guy is kind of included in both, then that's what allows us to say that 1 has to equal 2 plus 3. So example C3, says find the measure of angle y. It's an exterior angle, so y equals 70 plus 88, which tells me y equals 150. Whoops, should be 158. 158 degrees. Again, no different here, except now we have variables. Okay, so we have 3x minus 9 equals 73 plus x, and now you just use algebra. Subtract x, add 9, so 2x equals 82. Divide both sides by 2, tells you x equals 41. And this says find the measure of angle DCB. So just plug this guy back in here. 3 times 41 is 123 minus 9 is 114 degrees. Part B, no different. Again, exterior angles right here. So the exterior angle equals the remote interior angles. Okay, so subtract 2x minus 2x minus 8 minus 8. I'm doing all these steps in one just for time's sake. Those don't cancel. Those cancel. 4x minus 2x is 2x equals. Cancel. 3 and 51 makes 54. Minus 8 makes 46. Divide both sides by 2 tells me that the value of x here has to be 23. And then that's it. If it said find an angle measure, then you have to take this x and plug it back in to your problem, obviously. Okay, example 5 here. It says find the measure of the numbered angles. So I have a lot of different properties I can use. For angles 2 and 3, I know they form a linear pair with the 58. So 180 minus 58 is 122. So this is 122, 122. Now I have 122, 20. That's 142. So 180 minus 142 tells me that the angle 4 here has to be 38 because they have to add up to 180. I'm going to do the same thing up top. 122 and 22 makes 144. 180 minus 144 is 36. Okay, and so there's all your angle measures. Again, just using a linear pair postulate and then using triangle sum theorem. Okay, all within the same problem. And then finally, example 6 says the front face of the wheelchair ramp shown forms a right triangle. The measure of one acute angle is 8 times the measure of the other. So if this one's x, then this one's got to be 8 times x. It says find the measure of the angles, of the two acute angles. Well, I know all 3 of those angles have to add up to 180. So when I subtract my 90 from both sides, I get 9x equals 90. Divide both sides by the 9. Tells me that the value of x here is 10. And so the measure of my two angles are 10 degrees and 80 degrees. Plug the x back in. Okay, so again, in this particular section, some things that you're already familiar with, maybe some things that you need to polish up on and you have not seen yet, but overall, hopefully you feel pretty confident heading into this chapter.